Have you ever watched a movie about somebody being stuck in a time loop? Like Groundhog Day, Edge of Tomorrow, even A Christmas Carol. The characters are doomed to keep repeating a loop over and over until they finally get it right. You've already learned about iteration when we introduced the iterative design process and how we can apply this same process over and over until your program is the best that it can be. Think of iteration like a loop. The loop will continue over and over until a particular condition is met. In this lesson, you'll learn all about iteration. We've already talked about iteration a couple of times. First time was when we introduced the iterative development process. We said that as an idea becomes a program, there's a process that you go through, and you repeat through the process as many times as it takes to make your program the best that it can be. Then we said that iteration was also one of the three major algorithmic structures that we focus on in this course. So to review just a little bit about iteration and what it actually means, you can see over here that we've got this sort of circle of arrows, and that's exactly what iteration means. Typically there is a starting point. Let's just say that this is the starting point right here, and the arrows show us that we move on to all of these different steps, and when we come back to the beginning, we just continue repeating through those same steps. So that's iteration. Iterations are synonymous with loops. Sometimes you want the computer to execute the same line of code several times, and that's done using a loop. So all iterations or loops are going to repeat a step or a sequence of steps until they are told to stop or a condition has been met. Benefits of iteration. First of all, as you might already guess, using iteration, using loops in your code is going to minimize the amount of code in your program. So instead of having to repeat the same sequence of instructions and copy and paste them 4, 5, 6, however many times, you can actually just put them in a repeat loop, and you don't need to worry about having more than just those particular steps. Secondly, it's very efficient. When you group repetitive tasks together, it helps you to create more efficient programs. And finally, you can imagine that with less code, debugging your program is going to be easier. And it's going to make it easier to try new things, to test new things. Iteration is definitely something that you want to learn how to use in your programming. So here's an example just from real life, eating cereal. And we all know that eating cereal can be a very repetitive process. So usually when you eat your cereal, it's kind of a mindless task because your hand is simply moving from the bowl to your mouth, from the bowl to your mouth. And it's a very repetitive process. So it lends itself well to this example. So step number 1, you pour your cereal into the bowl. Step number 2, you add milk. Step number 3, spoon a mixture of cereal and milk into your mouth. And you will repeat step 3 until the cereal is gone. That's a repetitive process, and you will repeat it until it's done because you can't continue eating if all the cereal is gone. And finally, of course, because you're good at cleaning up after yourself, you rinse your bowl and your spoon and hopefully put it in the dishwasher if you have one. So we definitely can see that this is an example of iteration. And if you were going to give instructions to someone, you would not want to have to say, put the spoon in the bowl, bring the spoon to your mouth, put the spoon back in the bowl, bring the spoon to your mouth, put the spoon back in the bowl, bring the spoon to... You would not want to have to repeat those instructions. It's much more efficient to just say, look, repeat these steps until the cereal's gone. All right, here's another pretty basic example, hammering a nail into a block of wood. So when you look at it this way, the repetition is immediately obvious. Steps 2 to 4 are repeated again as steps 5 to 7, 8 to 10, so on and so forth. And so each of these repeated section of steps is called an iteration. If we were to continue this algorithm, could you guess what steps 11 to 13 would be? What about 14 to 16, 17 to 19? And the question is, how many iterations would we need? When would we know to stop? And more importantly, if we actually ever needed to write out detailed instructions for someone else, like a robot, or someone who just wasn't at all familiar with carpentry, even a simple task like hammering a nail might become a really, really long list of instructions. But we don't normally think of tasks like this in such overwhelming ways. Instead, we simplify the task in our mind and we apply abstraction, taking away detail to make an action more simple. So clearly in this set of instructions, we might want to talk about when is the appropriate time to stop these instructions. Do we stop when the head of the nail is flush with the surface into which we are hammering it? Something like that. There are 3 types of loops, and I will tell you that we're going to cover all 3 of these because they're good to know and they're very useful in programming. One of them, for loops, is actually in the APCSP curriculum, but it's mostly focused on its use in working through a list. We'll talk about that in a little bit, but it is definitely a loop. Then we have while loops, and I will tell you that this one is actually, you won't see while loops on the test, at least not at this point in time, right this very moment, but we're going to talk about them again because they are useful. Repeat until you will absolutely see. Those are on the test and they are very useful and really easy to make in Scratch. Just as a note with regards to Scratch, I will tell you that Scratch does not automatically give you the structure for loops or while loops. They do not create those structures for you. However, I want to let you know and encourage you to use this knowledge. Once you really understand these types of loops, you can actually build them in Scratch using the My blocks or the blocks that you can make yourself. And once you know the type of input that and parameters that these types of loops require, you can build them yourself in Scratch. Let's first talk about for loops. So for loops are going to repeat a task or a sequence of instructions as many times as the for statement mentions. So here's an example. If you were asked to write a program that would print out everybody's test scores, and the teacher has graded all of the tests, let's say there are 20 students in the class and each of them have a score. However, your teacher wants to there was a question in there that was bad and he doesn't want to penalize students who missed that question. So he wants to actually go back in and add 5 points to every person's score. So what you need to do is go back through that list of 20 test scores and for each test score in the list, add 5 points. Right? So that's an example of a for loop. So we repeat through, we go to test number 1 and we add 5 points. Then we go to test number 2 and we add 5 points, and test number 3, and so on and so forth, for as many tests as there are. All right, then we have an example over here on the right. This is sort of a pseudocode-ish type of for loop, just to show you how it might look in a text-based form. We have sum equals 0. So apparently there's a variable called sum, and it is being set to 0 right at the very beginning of this little program. All right, so then we see that somehow there's a for loop here, and there's a little letter I, and there are 3 little expressions here separated by commas. And the first one says for I being equal to 0. The second one says I being less than 10, and the third one says I++, which is a way of saying that I will be incremented by 1. And then inside the for loop, inside these curly braces, the curly braces show where the instructions are for, which to iterate through. And we see that there's this sum variable is actually going to be incremented by the letter I. All right, so when we first go through this loop, sum is at 0. When we start, I is equal to 1, right? And we add 0 plus 1, and we get 1. Then we go back through it a second time. Now I is 2. All right, and once we've gone through and I is now 2, now sum is 1, and sum is equal to 1 plus 2. So sum is now 3. And at the very end of this, it's going to display the sum. So just a quick word. Again, you won't have this particular thing on the test. Your for loops will be mainly focused on actions on a list. But I equals 0 is the starting condition. I less than 10 is the condition to continue. And I++ means that we are incrementing I every time we go through the loop. And so that's just an example of for loops, and you will see those again when we start talking about lists. On the exam, in the reference sheets, this is what you'll see in terms of for loops. So you'll see this is kind of, it'll say for each item in list. Again, it exclusively uses the for loop for going through lists. So for each item in the list, it will repeat whatever the block of statements is. And it'll look like this in the visual pseudocode. For each item in list, and then here's the statements to be executed. And explanation is over here. Another type of loops are while loops. And while loops will repeat a task or a sequence of instructions for an unspecified or an undefined number of times while a condition is met or becomes true. So at the beginning of the loop, the condition will be checked to see if the loop should even continue. And if the condition indicates that the loop should continue, then the loop will continue, and it will continuously check to see if the condition has been met. And if the condition is not met, exit out of the loop. So an example here is while it's raining. Usually it's going to rain for, we don't know exactly how long. We can't really time it out because Mother Nature doesn't work that way. But we will just keep checking. Is it still raining? Okay, I'll stay inside. Is it still raining? Okay, I'll stay inside. Is it still raining? So we continue to stay inside while it's raining. On the right-hand side, you can see the example there, pseudocode or, text-based type of expression. So we can see that we've got a variable called x being set to 0, and that while x is less than 5, it is going to follow these two instructions right here, which are to print or display x and then increment x by 1. So as soon as x is incremented the first time, it's equal to 1, and then it's equal to 2, and then it's equal to 3, and all of those things indicate, yep, still less than 5, keep going. Then it's equal to 4, yep, still less than 5, keep going. And then it is equal to 5. So then we check, and it is no longer less than 5, and so the loop will exit. What you will find on the APCSP exam, and what you will be able to use directly in Scratch, are repeat until loops. This is similar to while, except it checks to see if the Boolean expression is true before starting. That's the main difference between these two. This type of loop is classified as an indefinite loop because we don't really know how many times the loop is going to execute until that condition is true. So the repeat until notation specifies that a loop should continue indefinitely until a particular condition is reached. So in the example of hammering a nail into the block of wood, that is an indefinite loop. We don't know the strength of the person with the hammer. We don't know how hard the wood is. And so therefore, we just don't know how many swings, how many times they're going to miss. We don't know how many swings it's going to take. So the exact number of swings of the hammer is indefinite. And that's the same thing as the repeat until. In pseudocode, or in the reference sheet, this is how you'll see repeat, just a straight repeat, where we do know it's a definite loop that we know it's going to be repeat n times, or 4, or 5, or 6, or something like that. So you will see something like this up here, where it tells you it's going to repeat n times, and presumably you will be told what the n is, and then there's the block of statements right there. And here's what it looks like in the visual pseudocode. Now we have repeat until, and now we see this condition, right? And it's in parentheses. So we know that that is right over here, a Boolean expression. Hopefully that's becoming familiar to you now. That condition is a Boolean expression that evaluates to true or false. And in this case, it needs to evaluate to false in order for the loop to run. All right, so now you are ready to start playing around a little bit more in depth with loops. Finally, it's important to note that most algorithms are not limited to only one of these three common flow patterns. And again, just to remind you of what those are, we've been looking at sequence, we have been looking at selection, and we've been looking at iteration now. So we've covered all three. And typically, most programs make use of a combination of these three patterns. Often, a number of selection blocks are arranged together in sequence. So you actually have a sequence of selection blocks. Or, as we saw earlier in the hammer and nail example, a sequential series of steps might be the block of code that's inside the loop, which are the instructions that keep getting repeated. And you can kind of see an outline here of how this would work. And so up here, you can see that we start off, here's the start of our program, and we have a sequence of instructions to start everything off, right here. And then we reach a decision point, all right? Remember, a diamond is a decision point, and it has the question mark there. So there is going to be either a yes or a no, or a true or a false. There are two possible choices here. And so here is where we would, possibly choose a path. The paths might meet up again later on, but they might not. All right, and so let's say we chose this path over here. Then this instruction right here is going to be executed. And then we have yet another question that needs to be asked, right? And an answer that needs to be given. And based on the answer here, if the answer goes this way, then that means something has to continue happening, right? And we have to continue through checking to see if this condition has been met and performing whatever instruction A is until that condition is met. And then once it is, then we go back over here and we actually do, surprise, surprise, we do meet up with the other branch of the program, right? And of course, on the other hand, it looks like it's possibly a little bit easier if the answer for this one right here goes this way, because here we just have another sequence of instructions and there are no other decisions that have to be made. So you can see how things can be combined with one another, that we don't just see these three logical structures in isolation. So a quick example of how you might see this on the APCSP exam. Basically, it's a robot problem, you can see that, and of course we know all about the robot, that the robot is a triangle and it's pointing in the direction that it's facing, and that any moves will be made in that direction. So we already know that. We know that a condition has been created called goal reached. All right, so this is obviously a condition that's going to evaluate out to a true or false. So we're going to repeat until it is reached. Now, of course, because it's a repeat until, we know we will absolutely move through these instructions at least once. All right, so the program will first check to see if the robot can move forward. All right, well, if you go over here and take a look at these, you can see that every robot is able to move forward, and so that will happen for all four choices. Then it's going to check to see if it can move right. Well, you can see that in all four choices, like let's just pick on this one right here, it's going to move forward, and then it's going to check and see if it can move right, and it cannot. And as a matter of fact, none of them can. None of them can move right. Then it's going to check to see if it can move left. And again, none of them are able to move left here. All right, and so the rotate right and the rotate left, those instructions will never be executed on this particular iteration, on the first pass through this loop. It'll just be a move forward. All right, now we're on iteration 2. And so now, again, we're going to go through this same thing, and we're going to check and see. And of course, all of our robots are now in the second square right here, right? So now we're in the second square. Now we're going to check again. Can we move forward? Yes, all of them can move forward. So all of them are going to move forward. So now we're here. All right, can we rotate right? Yes, all of them can rotate right. So they'll rotate right. Remember, rotating doesn't move. It just changes the direction that you're facing. So now all of our robots have rotated right and they are facing this way. Okay? Then it's going to check and see, can we move left? And none of them can. They're all blocked left. Okay, and you can see that it's going to continue, that as long as, like, for example, I'm just going to pick on this one here. As long as we can move forward, it's going to move forward. And this one is blocked in all directions. There's no place that it can turn. It'll move forward here, and then it will turn right. Again, no move. And once it turns right, it can move forward, and it can continue to move forward. So it's going to reach it. Again, because these are all right turns first, these are all going to work out. Right turn here, right turn here, right turn here. Now this one, it can't turn right, but it can turn left. All right, so it does have that option there. So once it turns left, now it's facing this way, and it can move forward into the gray square. Over here, then we've got, again, we can move forward, we can move right, and so it will. And it can't move right here. It cannot move to the right, so then it will turn to the left. I should have said rotate. It cannot rotate right here. And so it will actually rotate left and then move forward into this square and here. And it's going to check for a right turn first because this box is to its right. And thank goodness it's going to check for, can it rotate right first, because that's what it will do. And it will reach the gray square. Now, this one, as you may already have noticed, this is the one where we're going to have a problem. So again, we reach here, we check to see, can we move forward? No. Can we rotate right? Yes. All right, here we go. And we'll go through, and again, as long as we're making right turns, just like with the other ones, we're good. Now this way, the right turn is blocked. We can't turn right, so that's fine. Then it will check to see if it's left. Yep, good. And then it's going to come right up here. Now here's the problem. The sequence of if statements, and I'm going to use those words over here. The sequence of if statements checks to see if you can move forward, cannot. Then it checks to see, can you move right? Yes, we can. All right, and so it can rotate right and then move forward. Then it's stuck. It cannot go forward, it cannot go left, it cannot go right. Okay, so that's the problem. So this is the one right here that is going to not allow our robot to reach its destination, which is the gray square. And again, that requires you, if you get a question like this on the test, it means that you have to understand both the sequence, that the sequence matters here, and that the repeat is going to happen until goal is reached. Okay, and once goal is reached, we don't have to worry about accidentally moving past the gray square because the loop will exit. All right, so there you go. We've learned all three of the logical structures that we're going to talk about, and now you'll get the chance to apply them.